Well, like my friends at Monty Python would say, now for something completely different. So, everyone is familiar with what graph paper is. Here is some square graph, quad graph we call it, right, because it's four-sided. And there's usually a whole bunch of little squares on the paper, and we use them to draw straight lines, and we want our lines to be straight vertical and straight horizontal. Okay, well with isometric that's not going to help us because we don't need vertical and horizontal. We need lines that are at 30 degrees to horizontal. So we have some isometric graph paper here, and this is another asset we can download and print from the print-free graph paper website. In addition to the square, quad, Cartesian graph paper, there's a number of different graph papers in here. Engineering graph paper, and again we get to choose the size of the squares. I've seen 1/5 and 1/10 of an inch increments. There we go. That looks more like what I was expecting. Polar graph paper. You ever hear of polar graph paper? I hadn't. There's some crazy graph paper on here. Don't know what I would use this for, but it looks cool. I have to say, I'm impressed. Logarithmic graph paper, 1/5 inch semi-log. Let's take a look. I mean, wow. Some of these must be like graph paper for plotting out time travel or something. They're just crazy. Probability? What is probability graph paper, right? Ever hear such a thing? So depending on what area you're working in, if you have use of graph paper, chances are, oh, here's my favorite, Smith chart. Something to do with electrical current because there's ohms involved, right? I mean, that's the craziest graph paper you've ever seen, you have to admit, right? So hexagonal graph paper. Alright, so this would be if I'm going to have some wicked Dungeons and Dragons mapping going on, I guess. Bunch of hex connections. Alright, very nice. So, lots of different graph papers in here in addition to the regular square graph. The one we're probably going to be most using, isometric graph paper. Right, because we're going to draw an isometric projection. So isometric graph paper, 8.5 by 11, drawing in inches. Let's set it to 1/4 inch isometric squares. Let's print. Let's take a look. And there we go. We'll have vertical lines on the graph paper. We'll have lines that go up to the left at 30 degrees and up to the right at 30 degrees. You'll notice that the paper is oriented long ways up and down, and you have to hold it that way if you want to have a 30-degree angle. Because if you turn it sideways, you'll have a 60-degree angle, and that's not going to give you an isometric drawing. It's going to give you garbage. Okay, so same deal. You print, and when it loads it up, you can right-click and hit print, or you could save it with a download, or you could just print it directly out of the browser, as many sheets as you want. Okay, so I'm using my isometric graph paper here, and I am holding it long ways up and down. And that's kind of important because if you hold it the other way, if you hold it long ways left and right, you're not going to get a 30-degree angle, you're going to get a 60-degree angle. That's definitely not the angle that we want to use for isometric. Okay, so hold it so that the 8.5 dimensions here and the 11 is going up and down. We will fold them in half just like we did before. And that'll give us a more than adequate amount of space to make our isometric sketches in. And then let's go take a look at our problems and see what we're going to be working with. Oh, hey, these look familiar. These are going to be pretty much the same things that we did with the oblique exercises, the same shapes except drawn in a different pictorial style. So, the deal with isometric is everything starts out with that shape right there. I call that shape the chicken foot because it doesn't look like a little bird's foot or something. Yeah. 3 lines. Pick a point and go up, vertical, up to the right, up to the left, both of the inclined lines are at 30 degrees. You're going to follow the graph paper. Right, and the location where you pick, I'm going to pick a little bit off center, down to the right of center. Okay, and then to set up our first problem, I'm going to draw 3 lines. I'm going to draw a line up to represent the height of the part. I'm going to draw a line up to the right to represent the depth of the part. I'm going to draw a line to the left to represent the width of the part. Now notice, nothing is horizontal, right? There are no horizontal lines here. Things are either vertical or inclined at 30 degrees in one of the 2 directions. So these are all isometric lines. They all fall on the isometric axes, which you can see easily is part of the grid. How are we going to turn this thing into our 3D shape? Well, quite simply, if you went this far back down here, go that far back up here. If you went this far down here, go that same distance down over here. If you went this far up here, well, let's do this. Let's lightly project a line back along the grid. Let's lightly project a line up. And you know what? The intersection of the 2 will show you the corner of that front face. And then last but not least, project up to the right here, project up to the left there. And there is our rectangular prism drawn in isometric. So no horizontal lines anywhere. We do have a lot of vertical lines though, and vertical's fine. There are lines on the graph paper to help you to stay vertical. Okay, and the width left to right is here. This would be the front. The depth front to back is here. This would be the right side. And then the width and the depth together will be shown in the top. So all 3 faces, all 3 surfaces shown in one view. Here's our next problem. Now understand, it doesn't matter what the shape is. As far as I'm concerned, the easiest way to do this is every shape starts off as a block. And you just chisel away at the block. So to make a block, you need a chicken foot, right? And then once you get the chicken foot, you make the vertical line for the height. You make the up to the right line for the depth. You make the up to the left line for the width. It'd be like if I went down to the wood shop and I said to you, hey, make this thing. See, you'd have to find a piece that was wide enough and tall enough and deep enough, right, in order to be able to cut it down into the shape you wanted. So we'll make the height and the depth and the width all part of our sketch. And when we got it like we want it, we will take that depth and go the same up here. We're matching. We'll take this width and go the same over here. And we'll take the height here and make sure it's the same height here and the same height here. Okay, now it doesn't quite look finished though, does it? A couple things we need to do. We need to take this corner up to the right and this corner up to the left. Now we've got our block to work with. All right, so this is our starting point. And if we were doing this on a piece of paper with the tools and try to make it look perfect, of course we would do this really lightly because chances are we're going to have to erase some stuff in order to create our finished shape. Have you noticed that everything is parallel? Have you seen how this line and this line are parallel? And how this line and this line are parallel? And this line and this line and this line are parallel? Isometric, if the surfaces are horizontal or vertical, they just follow these parallel edges. They're really easy to make. And then look at corners. This corner went up to the left and down. So this corner here will probably do the same thing. And it does. It goes up to the left and down. This corner here goes up to the right and up to the left. So the corner above it goes up to the right and up to the left. So it's kind of like a step-by-step puzzle. It's not that hard after you do a few of these to start getting the hang of it. Okay, so let's go back to making our piece. How do I get it to look like that shape? Well, where is the shape? What do you say? Front, top, or right side? Yeah, it's the front, right? Because the top is two rectangles and the side is two rectangles. That's really not the shape of the object. But the front, it looks like the letter L. So what we can do is we can go to the front view and use that vertical line here and use a 30-degree line here to create that L shape that's going to be on my front. And I mean, you know, make it wherever you want. Again, we're not measuring anything, so don't flip out. But if it's not up to your spec, you can always go back in and adjust it a little bit. All right, so this is the shape I want. Does this look like a 3D object that's an L-shaped block? I hope not, because you know what it looks like to me? It looks like a block that someone drew a couple of lines on. You see, it hasn't had any material removed yet. So to show that the material has been removed, here's what we're going to do. Look at this corner here. Go to the next corner adjacent to it. Do you see how this goes up to the right? Well, remember parallel lines. Whatever happens here will happen here. So if that went up to the right, this goes up to the right. How about over here? Right, these are our two new lines, our three new points. If this went up to the right, this will go up to the right. And how about here? Well, if the line above it, the corner above it went up to the right, this will go up to the right also. Okay, and on all of these I've gone on the grid, following the grid, and I'm going back the same amount. How about here? This line goes down. So from that point, we should expect that there'll be a line that goes down. And then how about here? We have a point that goes up and down to the right. So here is the point on the back. It should also go up and then down to the right. Okay, what we see now, at least I hope what you see, is you see the part we're removing as well as the part that we are keeping. Okay, when we're all done and everything is erased, here is our finished shape in isometric. You can still kind of see the little ghostly outline of where the part is that we had to cut out or remove in order to make the finished shape. Let's go on to another one using our isometric graph paper. Fold it in half. Same idea. Find a chicken foot starting point. Line is a little bit to the right of the center and a little bit low, maybe 2 or 3 blocks above the fold. Our next shape looks like this. And no matter what the shape looks like, it's always going to start off as a block, right? So I'll guesstimate the height, I'll guesstimate the depth, and I will guesstimate the width. And then I'll go in and start adding some parallel lines. So I can make edges, and then closing edges make surfaces. Right face. And top face. Now you see here what happens if you don't go low enough, or if your part's a little too tall, how I went off the grid. But I mean, poking out a little bit off the grid's fine. If we're just sketching, there's no biggie. Okay, so I need to turn this into our shape. So how do we do it? Well, same thing. Which face, which surface shows the shape? Is it the front? Is it the top? Is it the right side? The top is 3 boxes, 3 squares. That's not the shape. The right side is 2 squares. That's not the shape. The front looks like an upside down letter T. Ah, that's the shape. So what I'm going to do is real lightly go in there and think about how far in I want to go and how far up I want to go. Kind of plan out what I want to draw before I go in there and burn it in with some dark lines. There we go. Okay, so that's the shape. But if we just leave it like this, it looks like someone took a rectangular prism and painted those lines on the front of it. Doesn't look 3D yet. So remember what we need to do? All of these new corners we've added, they need to project back either up to the right or up to the left. So this corner at the bottom went up to the right, means the corner above it will go up to the right. This corner here goes up to the right, means this corner will go back the same amount up to the right. The corner above it, up to the right. The corner adjacent, up to the right. The corner below it goes up to the right, but guess what? We can't see it, right? It's behind the part. The corner over here, up to the right. Now, this one would continue a little bit, but again, we can't see it because this part is in front of it or obscuring it. Now, this corner goes down to the right, means the corner behind it goes down to the right. If this corner goes down vertically, means this one goes down vertically. If this corner goes down to the right, means the corner behind it also goes down to the right. And then we darken what we want to keep. We can eliminate completely, or if it's super, super light, if you did your layout super light, you can leave behind actually the box work that you started with, that bounding box. But most of the time we press a little too hard and we don't want people to be confused going to see our drawing, and the outlines of our sketch and drawings always need to be nice and dark and clear. Alright, so that is our next example. We'll take a look at our next one. Okay, so we see our shape. Simple rectangular prism with a square hole punched through it or cut through it. So we'll set up the height, we'll set up the depth, we'll set up the width, and we've got them all set up. We will create the faces. Here's the front face, or the front surface. And here is the right side face, the right side surface. And here is the top. And there's our block to work off of to get started. Alright, so the square on the inside, I'm going to come in a little bit, maybe 2 boxes all the way around. 2 boxes in, 2 boxes in, 2 boxes up, 2 boxes over, to create that square cutout, or cut out with square corners is probably more precisely wording it, since it's not a square. And then how do we show that this is not just a box with a little square painted on the front? Because it doesn't look like a 3D box yet to me with a hole cut through it. Well, the reason it doesn't is because think about corners, right? Corners are projecting up to the right, up to the right, up to the right. This one would project up to the right, except we don't see it. How about this corner? Does it go up to the right? Well, it should. 1, 2, 3. 1, 2, 3, 4, 5. I went 5. 4, 5. So you should go back the same amount down there that you went back up here. Okay, so now what are we doing? Why is there a line there? Well, think about it like this. This is a wall, and this is a floor. And if you look around your room, what happens where the vertical surface, the wall, hits the horizontal surface, the floor? Well, doesn't it create a corner? No. So if you don't have the line, the drawing's kind of awkward looking and incomplete looking. You need that in order to finish it up. Now, how come I don't see anything else? How come I don't see the back corner? Well, because this is thick, right? I went back 5 and 5 and 5 and 5. If it was thinner, let's see what it would look like if it was a little bit thinner. Maybe you made yours thinner. How about if we went back 3? 1, 2, 3. And 1, 2, 3. I mean, here we go back 1, 2, 3. And then what? Well, what happened here? It went up. So here it would go up. And then over here it goes down to the right. So over here it would go down to the right. So if we made our box skinny or narrow, then down here it should be just as narrow. And in this case, we see the back edge of the cutout because the material is so thin. I'll set up my next one. Chicken foot. What does our shape look like? So now don't be dismayed. This is not as difficult as you might think. Think about Leonardo and Michelangelo. Right? You give the man a block of marble and you let him start chipping at it, and eventually you got something perfect and beautiful. So that's all. I'm going to give you a block of marble to work with, and eventually, after some chipping, we'll have what we need. Okay, so here's our block that we're going to work with. Can you identify the face or the surface that shows the shape? Well, once again, it's the front. The side is 3 rectangles, not helpful. The top is 2 rectangles and a hidden line, not helpful. What's helpful? The front. So let's try to replicate what's on the front in the 3-view drawing onto our drawing in isometric. All right, pretty happy with that. Okay, so not complete until all of these new corners have been projected, right? Right now it's a block and someone has drawn some lines where they want to cut away material. They want to cut away material here. They want to cut away material here. But the cutting hasn't happened yet. So let's play the what's happening on the adjacent corner game. See, the adjacent corner here goes up to the right, so the corner here will go up to the right. The corner here goes up to the right, so the corner below it should go up to the right, the same amount. The corner here goes up to the right, so the corner here should go up to the right. And so on, and so on, and so on, right? And then what? Well, this corner goes down to the right, so the corner behind it should go down to the right. This corner is vertical, and this corner should be vertical. This corner down to the right, this corner down to the right. This corner vertical, the corner behind it will also be parallel and vertical. And then we can go in, and we can do our erasing, so that when we're done, we've got our finished figure, and it's nice and dark, without any extra stuff on the screen to confuse us. What do we do when we have slopes in isometric? Well, glad you asked that. Remember, these lines on everything we've sketched up to this point have been isometric lines. They follow the isometric axes. Right? We haven't had a case where a line did not go either vertical or along this axis or along that axis. When we work with angles, though, we will, and that's going to be a problem. So let's talk about how to do this. Just like before, everything starts off as a block. Okay, so find your start point, and then we'll look at our shape, and we'll think about what kind of height would work, what kind of depth would work, and what kind of width would work. Okay, and we'll create our front surface, our right side surface, and we'll create our top surface. Looks pretty good. Okay, so now I know the instructions say that's a 30-degree angle. Well, the paper's already at a 30-degree angle. And if you put the 30-degree angle here, look, it's not going to give you a slope, is it? So how do we get the 30-degree angle? Do we take another triangle and put it on here with the 30-degree? Do you put the triangle on the 30-degree lines to get the angle? You know, the answer is none of the above. The answer is I have to convert my diagonal distances into linear distances, which means, hey, how tall is it? What is the rise of the figure? And then what is the run? How wide is it? So I care about where does the ramp start? Up here. Where does the ramp stop? Down here. And then connect the dots. Okay, that's it. Connect the dots. And then whatever you did in the front, of course, you have to do in the back, right? So go back here, and then you're aiming for here. Connect the dots. All right. If I gave you a block of wood and I said, hey, turn it into 2 wedges, wouldn't you do this? Wouldn't you just saw it from corner to corner to make 2 wedges? And that's what we just did, right? So we're going to take off the extra part we don't need. We'll look at what's left over. And what is this angle? You know what? I couldn't tell you. Number 1, we didn't measure it. Number 2, it doesn't matter. When you're working with non-isometric lines, we don't have to worry about the angle that we're working with. We don't have to worry how long they are. We just have to worry, did I start it at the right point? Did I end it at the right point? And those points are determined by measurements. How tall? How wide? And then the rest is just connect the dots. We'll set up our next drawing. In our next drawing, here's our shape. Okay, got our shape figured out. We need to make our chicken foot, and we need to make a line for the height, a line for the depth, and a line for the width. Okay. Front, right, and top. How does the shape on the screen that we're working on become something in isometric? Remember, the paper is at 30 degrees. I need a 45-degree angle. Does that mean I should take my 45-degree triangle and try to line it up with 30-degree lines to make the angle I need? Well, no. Look at it. It looks stupid. This isn't going to work. So again, you need to know where to start the slope and where to end the slope. If I look at my sample I'm working off of, my slope starts somewhere around here on the front, right? And then it ends down here on the bottom. So, where do you start? Where do you stop? And that's it. You need this distance from here to here, and this distance from here to here. And then the rest is gravy. I have no idea what the angle is. Doesn't matter. It will not measure correctly in isometric because it is a non-isometric line. Whatever I did in the front, I need to do in the back. So I will bring this edge back and this edge back. And to create the slope, we'll just play connect the dots. There we go. All right, the part we would cut off or remove is over here. And we'll darken in the parts we're going to keep. And there's our little sketch in isometric. All right, so some of these shapes can be a little trickier. Don't give up. Let's just try it. Let's see how it works. Give yourself a starting point. Make your block. Okay, the shape is on the front, as has been happening all the way through here. So I'm going to draw the shape on the front again, like I did before. And to make the angle, here's what you need to know. How far over to start the angle? And then where is the bottom? Where's the V? Where's that vertex, right? How far over and how far down is it? And when you've located that point and this point, you can create the angle. And then for the other side, same thing. From here to here, that creates your angle. Okay, so let's draw and darken in at least the parts I want to keep. The parts that show me the overall shape. Okay, and how do we turn it into isometric? Well, look at every one of the corners that you just created. They all need to do something. Let's do something. And for a clue, let's start down here. What happened to that corner? Well, it went up to the right. Now this corner goes up to the right. 1, 2, 3, 4. This corner goes up to the right. This corner goes up to the right. Up to the right. Up to the right. Up to the right. You go up to the right. You go up to the right. B's for everybody. Okay, and then down to match the vertical line here. Down to the right to match the line in front of it here. Okay, mostly there. Mostly there. What happens next is a little bit tricky, so we'll take a little pause to erase some stuff that we don't need to see. Okay, how do we create the back edges for this V? See what I did in the front. What do I do in the back? Okay, so basically on each corner we went back 1, 2, 3, 4 diagonal. So I'm going to do the same thing here. 1, 2, 3, 4. Now the point is back here, but you know what? I can't see it. It's blocked by the object. But just because I can't see it doesn't mean it's not important. It's going to help me to do two things. Number one, it's going to help me to know where am I going to aim for as I'm making this line. So I'm going to aim for that point. And then, do I see any of the slope on this side? Well, that would depend. If you drew yours wide, you might see some of the face down here. Okay, but if I go from here down, see, I can see that that slope, that would not be visible from where we're looking. So I'm not even going to add anything, right? No hidden lines, nothing too technical. Trying to keep it simple. And then our shape is super duper. Okay, we finish it up with a little bit of drawing, and then away we go.